So the practical electrical circuits, we have what are the dangers of electricity? When we use electricity, there is a chance that it might um, start a fire or explosion might happen or occur, or there might be an electrocution or electric current, may electric shock, we can say. So how we can, what are the causes of these dangers? One is the damage insulation. Insulation, the layer on the conducting wire which protect us from electrocution. So on the electrical wire, that insulation might be damaged. If the insulation is damaged, if a person will touch this wire, what will happen? He may get an electric shock. So one of the danger of using electricity, if there is a damaged insulation, then what might happen? We may get electric shock. That is one. Another is, like as you can see here, this is also a wire is shown with a damaged insulation, so which may leads to electric shock. Another danger is a overheating of the cable. If we use so many devices in one unit, as a result, it will draw too much current. When it will draw too much current, current and the heat are directly proportional. If we have more current in the circuit, it will produce a greater amount of heat energy. If a large amount of heat energy is produced, then what might happen? It might damage the socket or it might damage the plug. And if when the plug damage, so it may come in contact with each other, the live wire, because for electricity, we need two wires to work. One is a live wire, another one is a neutral. So when you plug in any device and it is drawing too much heat, too much current, that as a result, more heat is produced. That heat might melt the component. As a result, it melt the component. So the live wire may touch the neutral wire and it will start a fire. So for a device to work, we always need two wire. One is a live, another one is a neutral. So when there is a overheating of the cable, if we connect or overloading, as a result, it produces heat energy, which may cause a short circuit or a connection. Short circuit means that if the live wire touches the neutral wire directly, we call that as a short circuit. And as a result of a short circuit, it might start a fire. Another danger when you're using an electricity, you may have a dam condition. In a dam condition or a moist condition, our body is not a good conductor, but yes, it does conduct. But when we have a moist condition, a moisture is there in the atmosphere, or our hand are also moist or a wet, and we touch any electrical appliance, so water can conduct and our body resistance decreases. So the dam conditions, because of the dam conditions, we may get an electric shock as well. So due to damage insulation, electric shock, due to overheating of the cable or overloading, it might start a fire, and due to dam condition, we may get an electric shock as well. Overheating means when we connect so many devices, it produces heat because the current produces heat. And as a result of this heat, the device, the socket might melt. And when the socket melt, it might produce it may cause a short circuit. Short circuit means when a live wire and a neutral wire touch each other, we call that as a short circuit. So we have a live and a neutral wire, and there's a device. What is a live wire? In a live wire, the charges are actually vibrating. In a neutral wire, the charges are not vibrating, and then they complete the circuit. So the charges, when they move, vibrate in the live wire, they're transferring their energy to the electrical circuit, and the remaining is transferring back to a neutral wire. That's how the device will work. Any device will need a live and a neutral wire to work. In a live wire, the charges are vibrating. In a neutral wire, the charges are not vibrating. So when we make a complete circuit, that is known as like the closed circuit. So what might happen? How much current or a voltage is handled by the device depending on what it needs. Like example, a computer, a CPU need a different amount of a current as compared to a television. A television required a different amount of current as compared to air condition. Air condition need a different amount of current as compared to electrical heater. But if a device need a large current, then it will produce more heat energy. How to measure a current is by an ammeter. How to measure a voltage is by a voltmeter. What is the meaning of the term heating of a cable or overloading? When we draw too much current, like we connect so many circuit components to the socket, all are drawing the current. When all are drawing the current, what it will produce? It will produce a heat energy because current and heat are directly proportional. If it's a greater amount of a current you draw from the circuit, the higher heat energy it produces. So as a result of this heat energy, it might melt this socket. When it melts the socket, so the live wire may touch the neutral wire and it produces a short circuit. And as a result of a short circuit means if the live wire and the neutral wire combine with each other. And as a result, when they combine with each other, it produces a spark or it may start a fire. Is it clear?
Yes, sir.
So the first we started with the damage insulation.
Yes, sir.
What is the meaning of the term damage insulation? The covering on the conducting wire, that is so called insulation. So if it is damaged, you may get an electric shock. That is one possibility. If a overloading or a overheating is there happen in the cable, that it cause a short circuit which may start a fire. Then the second another thing is electric shock means when you touch any appliance, your body will act as a conductor. So the current will pass through your body. If any conducting material is there and you touch that, so the charges will flow through your body. That is how the electrical conductor body conduct electricity. So in a damp condition or a moist condition, our body resistance is low. As a result of the low body resistance, we can allow our body can allow electricity to pass through. So likely you will get an electric shock when you have a moist body as compared to that of a dry. So in a damp condition, if, for example, if it rain outside, you're not supposed to touch any electrical devices or electrical appliances because your body resistance is relatively low as compared to that of dry. How we can make the electricity safe or make a safe use of electricity? We can use the fuse. The purpose of the fuse is actually used for the safety of the device. The purpose of the fuse is for the safety of the device rather than the safety of the person. Example, you're using a television and you plug in the television. Here's a socket. You have in a socket, it can be a 3-pin, it might be a 2-pin. And you plug in your television. The pins are made up of a conducting material, usually made up of copper, and the wire also made up of copper. So when you plug in, the current, like when the plug it's in contact, the current will flow through the live wire, energy will transfer. it will enter the circuit because inside there's an electrical circuit which uh, affects the working of a television. So the electrical circuit is there inside and the television start to work. Example, for a normal working, your television required 3 amperes to work normally. But suddenly, from the live wire, that very high current enter. Like example, your television need 3 ampere, but suddenly from the live wire 10 ampere enter. So if the 10 ampere enter, 10 ampere will produce too much heat energy. As it produce greater amount of heat energy, what will happen? It might melt the circuit in the television because 10 ampere produce more heat energy. So it might damage the circuit of the television. Then what you have to do, you have to replace the television, which is expensive. So for the safety of the device, if we want to make the safe use of we want to make the safe use of electricity for the appliance, then what is there? In a live wire, there's a circuit component connected, and what we call circuit component, we call that as a fuse. So a very thin wire is connected. Usually fuse is installed in the plug rather than here. Usually fuse is in the plug. Instead of in the directly in the wire, it's installed in the plug. And every fuse is having its own rating. What is the meaning of the term fuse rating? Every fuse allow a certain amount of the current to pass. If I say a fuse rating is 3 ampere, means it can allow 3 ampere to pass through. The purpose of the neutral wire is to make a complete circuit, because what will happen? The electricity will enter from the live wire, move in the circuit and return back to the neutral wire. So neutral wire, the purpose of the neutral wire is to make the complete circuit. If there was a neutral wire, only live wire is there, then the circuit will not work. A student asked a question, if we drop a water on a socket, it will usually start to burn. What is that? The reason is that if you drop a water in a socket, so that water allowed the conduction to happen. So the live wire and the neutral wire will come in contact with each other. So when electricity flow from a live wire to neutral wire directly, it will produce a spark or a fire. That is why in case of a fire due to electrical appliance, when any electrical appliance is burning, don't put a fire by putting water on it. You are not supposed, because if you put a water on a electrical fire, like fire which is started due to electricity, it won't stop. It will enhance that because water start to conduct electricity. So whenever you want to put out the fire, because it started with a electrical spark or electricity, then you should put any insulating material rather than water. So what is the purpose of the fuse? The purpose of the fuse is to protect the device. When you plug in the socket, yes, if other than electrical fire, you can yes use water, but not for electrical fire. If you see a burning television is there or a burning socket is there, don't put off fire by putting the water. That is not the right thing to do. Yes, you can use a sand. Any insulating material will work. Even you can use a wooden stick to disconnect the circuit, live wire and a neutral wire, but not any conducting material. So when we plug in this device, if a 10 ampere is a very high current for the device. So we want to protect this device, a television, from a high current. So inside a plug, there's a component which is attached, and what we call this component, we call that as a fuse. What is the purpose of the fuse? The purpose of the fuse is to protect the device from a very high current. How it will prevent from a very high current? Like, and every fuse is having its rating. Like example, if your television required 3 ampere to work, So what you will select a fuse a bit more than that. So you will select a fuse rating of 3.5. So if the current in the live from the live wire is 3.5, it will allow. But if the current is more than 3.5, the fuse will melt. Because of the high heat energy, this fuse will melt. When the fuse will melt, the circuit is being disconnected. So what you have to do, you just have to replace a fuse rather than replacing your television. So replacing a fuse is much cheaper as compared to replacing a device. So main purpose of the fuse is to protect the device by using the heating effect of the current. No, not additional. What will happen? Every fuse is having its own rating. Let's say this is a fuse. So what does it mean? If this fuse is having a rating of 4 ampere and suddenly from the device 10 ampere enter. So this 10 ampere produce too much heat energy. As a result, the wire will melt in the fuse. So when this wire will melt, what will happen? It disconnect the circuit. So no current is able to pass through in the device and your device is being protected by the high current. So the moment high current is there, the fuse will melt and the circuit will disconnect. Your device will not work. So only thing what you have to do, you have to just replace the fuse in the socket as compared to replacing a device. Is it clear?
Yes, sir. Clear.
Any question or doubt in this? If a television need 3 ampere, so why don't we use a 5 ampere, 3.5, why not 3? Because there is always a tolerance is there that a material can allow, or like example, if a television need 3 ampere, but it's not like 3.1 television will not work. It can work with 3.1, 3.2. Like that is not a very high current for a 3 compared to 3. But if a current is too high, then the device will not work. It will damage the device. Then the fuse is effective. So maybe you have seen the sockets. If you see your laptop charger, you can find a fuse there as well in your laptop charger.
Yes, sir.
So main purpose is just to protect the device, even if it is 3.5. So if we have appliance 3 ampere, why do we pick little more? Because as I mentioned, why we select a fuse rating a bit more so that it can allow more current, like because your device can work with a 3.1, 3.2, 3.4. It will not be very high. But what if the device need a 3 ampere and suddenly from the socket or the wire is 10 ampere? That is a very high current. But if it is 3.1, it is tolerate, the device can tolerate. So we have different rating of the fuse. We have 5 ampere fuse, 13, 15 and 30 ampere fuses. When the no, no, not only these values, the certain values are available, like here it is mentioned, but we can have, according to the question, we select a fuse. Like these are the standard values which are given, but according to a question, you can decide your fuse. If a water falls on an insulating material, you will not get electric shock or it will not start a fire. If a water fall on the insulating material, I'm talking about if a water fall on a bare wire or a connection, like example, you have a plug, you plug in the device and there is a moisture. In that case, it might start a fire. So if there's a short circuit or a connection between a live wire and a neutral wire, then yes, it will start a fire. If a drop of water is there on an extension wire, maybe why the fire may not start because it does not make a complete circuit. Like here, you have extension, and there's a drop of water here. But that drop of water may be not connection, making a connection between a live and a neutral wire, so it won't start a fire. Sometime if you touch, yeah, when you touch a button, when you have a moisture reduces the body resistance, so it allows the current to pass through. So if a live wire touch the neutral wire, definitely it will start a fire. Otherwise, in other case, it won't start a fire.
So, sir, fuse basically stops the overheating of cables, right? The main use of it.
Overheating of a cable, rather than overheating of a cable, its main purpose is to protect the device rather than the cable. Like,
Okay.
it's the main reason for using a fuse is to protect the device. The main purpose of a neutral wire is to make a complete circuit. If there was no neutral wire, let's say you have a device and there is only live wire. Will it work? It won't work. Why it does not work? Because let's say this is an internal circuit. The charges need a complete circuit to flow. So charges are moving in the live wire, but where they will go after transferring energy. So there must be a complete circuit. That's why to make a complete circuit, there is a neutral wire as well. So when you plug in any device, the charges transfer energy to the device or the component and flow through a neutral wire. So it's making a complete circuit. Why there are certain values of the fuse which are labeled? Because the thickness of the wire which we use, different standard thicknesses are used. That's why the fuse is having different ratings. Like the thickness of the wire will affect the rating of the fuse. Earthing, we'll discuss what is the role of earthing, but right now, earthing is for the safety of the person. So inside the fuse, what is present inside the fuse? Inside the fuse, there is a thin metal wire is there. If we change the thickness of the wire, the fuse rating will change. Like if I say a fuse rating is 30 ampere. So a 30 ampere fuse rating means the wire which is used can allow more current. So much thicker wire is used. But if a fuse rating is only 3 ampere or 5 ampere, so very thin wire is used, which can melt easily. So we can change the thickness of a wire, and the changing a thickness of wire, it allow different amount of current to pass. So as a result, the fuse rating will change. Capacitor is not part of the circuit. Capacitor is not part of circuit. It was there before 2023, not now. So example, an electric fan has a rating of a 460 watt. So electric fan has a rating of a 400 and copper is having a high melting point, but when you take a thin piece of a copper, its temperature rises because thin piece is having a low resistance. So as a result, it will expand because of the heat energy and melt. It's like the expansion causing a breakdown of the connection. So electrical fan has a rating of a 460 watt on a 230 volt main. What rate of a fuse should be fitted? So first we'll find the current. How to find the current? Power is a product of voltage and current. So current is power divided by voltage. So 460 divided by 230. So our device need 2 ampere to work. So what fuse should be fitted here? Therefore, we select a 3 ampere fuse. As you can see in the previous example, some standard fuses were given. I've listed some standard fuse like normal fuses. Certain fuse ratings are there 5, 13, 15 and then 30. These are one which we normally use. But according to this example, If a device need 2 ampere, so I can select a bit more than that. I can select like 3 ampere for this to work. 2.5 will also work. For example, if you have electric kettle and the pad that heats up the whole kettle and the water and the socket, some water drop falls on the pad. Is it possible to short circuit? Under these conditions, if the all the water spill on this on the base of the kettle, yes, there is a chance that it might cause a short circuit. If it is spill on the platform, the conducting part, because the electric kettle, the base of electric kettle, the center part is a conducting material. So if any water is there in this conducting part, yes, it can cause a short circuit. Is it clear, the concept of the fuse? Anyone having a doubt or a question about fuse?
No, sir, clear.
Then for a safe use of electricity, we also use, won't the earthing prevent the circuit to? We will discuss about earthing wire. Right now we are discussing the different, so first one is a fuse, the next one is a switch. You can see here, we use the switches. What is the purpose of the switch?
To stop or to let the current pass through.
Why does the fuse rating to be large? So that the device can tolerate. If a device need 2 ampere to work, if a current is 2.1, yes, it will work. If it is 2.2, yes, it will also work. 2.3, it will work. Like the main reason for selecting a high fuse than what the device needed is because it can work with a high current as well. But if the current is too high, then it will produce a lot of heat energy, which as a result may damage the device. So if you have a device which need 2 ampere to work and you select a fuse also, you connect a live with the neutral wire and you select a fuse also 2 ampere. So even if the current is more than 2, like 2.1, the device will switch off. That circuit will, that because it's more than the fuse rating, so the circuit will disconnect. So whenever we select a fuse, we select a value a bit higher than what our device need. If we need 2, okay, fine, 3, 2.53. If we need 3, 3.5 or 4. Is it clear? Anyone having a doubt or a question till this point?
Clear, sir.
Use the chat to answer these questions. Why is a fuse used in electrical circuit? And I want participation from everyone. Why is a fuse used in an electrical circuit? You can use the chat to answer these questions. A, B, C, or D. The correct answer is B. Why B is the right answer? Because the purpose of the fuse is to prevent the current becoming too large. If the current becomes too large, it will damage the device. So to protect the device from a very large current, we use a fuse. Another question. The current in the kettle is 10 ampere. The kettle is protected by a 13 ampere fuse. Like, let's say you have a kettle. your kettle works normally when there's a 10 ampere, okay? And it is protected now. The fuse which is protecting that has a rating of 13 ampere. We have a live wire and a neutral. The owner of the kettle replaces the 13 ampere fuse with a 3 ampere fuse. Like first it was fitted with a 13 ampere, but not what he did, he replaces the 13 ampere with a 3 ampere. What happens when the kettle is switched on? So if the because the current in the live wire is 10 ampere, it will melt, definitely it will melt the fuse. So the fuse will melt. And when the fuse will melt, the kettle will not be damaged. That's why B is the right answer for this. The fuse melts and the kettle remain undamaged. A domestic circuit includes a 30 ampere fuse. This protects the wiring if there's too much current in the circuit. In which wire is the 13 ampere fuse positioned? And what does it do when it operates? Like which wire we connect a fuse and what it does or what it do when it operates, how it works. Is it A, B, C, D? You can use the chat to answer. So the purpose of the fuse is to protect the device from a high current and it always disconnects the circuit. So correct answer for this one is A. That fuse is always connected on the live wire and it disconnects the circuits. We have a fuses available at different rating. An electrical heater is plugged into a main supply using a fused plug. The current in the heater is 10 ampere. Like there's an electrical heater which is using 10 ampere to work. The cable is attached, is rated 15 ampere. Cable, look, every cable or a wire is also having its rating. Like you will see when you're using your mobile chargers, the cables are very thin as compared to when for an air conditioning unit, which is having a thick wires. Because for a mobile charger, we don't need too much current. So as it's not drawing too much current, that's why we can use a thin wire. But in case of an AC, it uses a large current to work, so the wire should be thick. Otherwise, the wire will melt. So wire is also having a rating of a 15 ampere. But whenever we select a fuse, we don't check how much wire can carry. We always select according to the device. So our device needs 10 amps. So what is the suitable fuse rating? So it should be a bit more than that. But the option which is available a bit more, that is 13 ampere is a bit more. That's why we select D as a right answer. Is it clear, this one? So we don't select, we don't bother about the cable. We ignore the cable. Any information about cable, you don't have to even see. Whenever you're selecting a fuse, you always select according to the device which you want to protect. Where must a fuse be connected in a main electric circuit? Earth, live, neutral. We have not discussed anything related to earth thing till now. So we will ignore these options. You have two, B or C. So the fuse is always connected on the live wire. So that's why B should be the right answer. Then we have a circuit breaker Maybe you have seen outside the main circuit of your or circuit unit is there. Maybe you have seen these type of switches on the main circuit. Have you seen these? Yes or no? So these are actually called circuit breaker. Switches, normal switches are there. In a outside main unit, these small switches are there. We call them as a circuit breaker. How a circuit breaker work? The circuit breaker used a magnetic effect as compared to a fuse which was using the heating effect. So this is a circuit symbol of a circuit breaker. Circuit breakers are also connected in the live wire. And circuit breaker is also having its rating. So we have a live wire, a device is there, and we have a neutral wire. But main purpose of a circuit breaker is to protect the home circuits, like main circuits in the room or in a unit rather than a device. So let's say this is one room. This room need 30 amperes to work. So and a circuit breaker is also having its rating. So circuit breaker is 30 ampere. So if the current is more than 30 ampere from the live wire, let's say 31, so because of the magnetic field, the switch will open. So this will automatically switch on like it is connected. But when too much current is there, it produce magnetic field, and that magnetic field cause the switch to open. So when the switch open, what we just have to do, we have to just reset. Reset means we have to just connect back again. So what is the advantage of using a circuit breaker over the fuse? That the circuit breakers have, we just have to reset as compared to a fuse which we have to replace. Another, the circuit breakers use a magnetic effect of the current